Going to my presentation. So I'm Curelet-Balan. I'm a data scientist. I work at Funnelcake, and with our company, they allow us to do some volunteer time. And therefore, I got a day off, so I'm helping out to prepare this presentation. And I'm glad that you are all coming today to join us. So the aim of this course of today will actually be how to build a data mining pipeline, because normally you always are involved in only one small part of the presentation, either the extracting part, cleaning part, or the analysis part, and therefore my aim today is build a whole pipeline for Twitter. The links for the files you will find on lubel.org or meetup.sit. I will each time actually walk through some examples, and you also will get some time next to work on everything. Feel free to ask questions anytime. If you later on select questions, you can reach me at mlubel@fortknox.org. And I just also try to have like a mix between like the theoretical concepts and the practical. Okay. Okay. So, outline of today. First part will be the preparation work. How will we actually be getting the tweets out of Twitter? What are all the packages that we will need for R? Afterwards, we will have the ETL. Okay. Start with the preparation work, authentication with Twitter API, are the packages that we need. Next, we have the ETL part. ETL stands for extract, transform, load. So we will extract the tweets from Twitter. We will transform the tweets. That actually will mean cleaning of the data, transforming the data to a structure that we can use in R, and eventually we'll load the data in R. When we have done all this work, that real text mining only can begin. We will look at frequency analysis, we will build a word cloud, we will do some clustering, and eventually we do some topic modeling. So for all of these topics, I always will first introduce it. You will be able to play a bit with the scripts, you look at the results, and then we go on to the next one. So for the preparation, we use, for connecting with the Twitter API, we use OAuth. That's a standard for authorization, and it actually means that you will generate keys that a third-party application will be able to use to log in as you, without that you need to give away your password yourself. So what do we need for this? First thing is a Twitter account. Second thing, what you also need now to use or the authentication is you need to add the phone number to your account. In case you haven't done it yourself, you log into your Twitter environment, click on your picture, go to settings, and next check mobile, and you will be able to put in your phone number. If you don't do it, you actually won't be able to get the API keys. Next, we will be making a new application in Twitter. It means going to apps.twitter.com/app/new. You'll be filling out all this information, and And if you next will go to keys and access tokens, you will be getting the 4 keys that you need. So you can now take some time to actually set up the Twitter authentication that you will have the 4 keys.
If anybody needs Wi-Fi, Wi-Fi.
Sorry, Twitter authorization, you can also already download the zip files and put it, extract the zip file in a directory and set this directory for your install packages. Further structures of the topics, what we will have, I always will shortly introduce a topic. I have built an R script for each of the topics, and you will be able to execute them when you open R and press source, the cool script that we made. Don't forget the double quotes, otherwise the script is not running. And I will go over the highlights of the scripts. We will briefly discuss the results, and you also will get some time to execute the scripts yourself. Later on, I also will pass by other people who still might have a problem, or otherwise just help out each other a bit. And so, like I said before, we had the ETL process. So we had extraction of the tweets, and what do we need? The Twitter library from R. Did I say to install packages? No. So like what you have here, and you have to change there, you will need to do source install packages .r, and actually it might be that you still need to select a mirror, and then you will be getting actually the packages of all of them that we will need. So Twitter, text mining, Snowball, you will see them all showing up later on. Okay, so just a quick question, who has the R authentication keys? Can you just raise your hand if you have them? Oh. Have them? Yeah. Okay. Otherwise, I still have also a backup plan that we just download Twitter Workspace, that everybody gets them, so. Okay. This file, the http://lobel.org/meetup.zip. Otherwise, try checking this one. Yeah. For you, just go to this site, http://rdataMining.com/data, and here you otherwise also will find some some Twitter data that you can use. For the extraction of the tweets, so extraction of the tweets is the first part of the ETL process. So you will have here the extract tweets.r package. We'll use the Twitter library, and in the setup Twitter OAuth, you will actually put in the 4 keys, what you have from your authentication. In case it doesn't work, you can download example tweets for the R data mining website. We will look for the Twitter handle R data mining, number of tweets we are maximum extracting, and we will be building the data frame of the tweets. Next, you will check, we will write all the different, we will write the first 2 tweets, tweet number 320, and that will look, for example, like this. You see first tweet, second tweet, third tweet, you see some URLs there, some extra information, and next you will be able also to extract, for example, the column names from the tweets. So the data frame, you will mostly use the text, number of rows, number of columns, and dimension. So you'll be able now to extract those ones. So okay, we'll be checking out the extra. Did it work for you?
I'm waiting. If you want, oh, you want? You know it?
Yeah.
You use it?
Yeah.
Oh, yeah?
graduated now? Like this now?
How much does it
Do you mind putting the slides just somewhere online? So then
Yeah.
we can just kind of.
So, the next part, the transforming of the data, we will need to clean the data. So if you look at these tweets, what are things that you actually think you don't need in these tweets, in this text for the analysis?
The links.
Yeah, the links. Other things?
Common words.
Yeah, common words. Stop. Jens would say them as stop words. What are things we also don't want to get rid of?
Punctuation.
Yeah, punctuation. These things, what would they mean?
Oh, smileys.
Oh,
Yeah, indeed, the smileys, the emoticons. We don't want, you can indeed use them for your text mining analysis, for the sentiment analysis. We'll currently not be using them. What are things from the first one that you probably don't want to use?
The date.
Yeah, the numbers indeed, we want to get rid of them. And then also what actually will help further the analysis. You see capital ones, smaller letters, so indeed you also want to normalize them. And what is something extra that we also still might want to do is,
Timestamp location.
what did you say? So, and also you will also want to actually normalize the words. So the steps we will be doing is, first we will be building actually a text corpus. Text corpus, what does it actually mean? It is a large set of structured text. For our case it will be, for example, if you're using R data mining, that will be the set of all the different tweets about it. In natural language processing, you have a lot of corpora. An example one is the Brown corpus, which was built in 1960. It exists of like 1 million words of running English prose text. It's built by taking 500 random chosen publication. Each sample has about 2,000 words. And this will actually, for example, allow you to do some statistical analysis, which type of words occur how many times. You can also check for some linguistic rules. A nice thing which is also available in those corpora is metadata, so which is actually part of speech tagging. How does this actually look like? If we check, for example, here, the word, this sentence, when you're tokenizing it, they refuse to permit us to obtain the refuse permit. And if you, for example, would use the NLTK package of R, you will be able to tokenize it, and you see they will be personal pronoun, refuse will be a verb permit. The second you refuse, you'll see it as a noun. You have, for example, permit, which is also just the verb form, and second time also the noun. So it is all information that you actually get in a corpus. We only just will be building the whole set of sentences and be cleaning it out. So, like I said, we will be cleaning data for performing a good analysis. Clean data is needed. The ones we came indeed with was punctuation, URLs, numbers, stop words, white space that we want to remove. We also said common words, so the stop words that we don't want to have. What is important also here for this application, we will be adding back in R, because in our case it's not a stop word, and big also in the context of big data that we will be adding in. And then we also need to deal with the emoticons. Second part will be stemming. So the normalization of the stemming. So we will all reduce the words to their stem. The algorithm that will be used is the Porter stemming algorithm, and it's the snowball algorithm, and it will actually truncate words to their radicals, caruses to carus, ponies will get to pony. I know it's different way you would expect the Y there, but it's the way that the rules work for the stemming. Carrots will stay carrots, cats will go to cats. And also an extra normalization will be done by putting everything to a lowercase. How does it look like now in reality? So you will have the library of the text mining, and you will actually build up here the whole source. This is this line that will work if you don't have emoticons, but if you have the emoticons, you need to actually use the UTF-8 encoding, and then they also will be dealt with in the correct way. If you convert everything to a lowercase, so it's transformation that we see here. Next, you remove the URLs with a regular expression, and anything different than just the normal letters will be removed here. We add 2 extra words here to the stop words, which we don't want to deal with, available and via, and the R we actually will be adding in, will be removing from the stop words because we want to use them in our analysis. If you look at the slides from R data mining itself, you're saying there's this extra step you need to deal with the text mining, and this is just that I put in for a note here that I also applied this step. So how will this exactly look like if you transform all the tweets? You will see tweets before and afterwards. You see nicely the URL has been removed, everything has been put to lowercase, and all the numbers are, like the punctuation, are also gone. And finally, you have the last part of the ETL process, which actually means just loading the tweets, and that will for us be the text term document format that you actually will build up a matrix, which all the different rows you have the terms, and all the different columns will be representing the documents, which in our case will be the tweets. Part of the text analysis. So you will see you have frequent words and associations, the word cloud, clustering, and the topic models. Frequent word associations. So we have the term indeed that we might expect to occur the most is R, because indeed it's about R data mining. And if you have from the term document matrix, you will be first checking on which row do we have actually R, and then we will just use that row together with the next 5 rows, and we will be inspecting the next 10 documents. So over here we see we have these 6 terms. The documents, you see R is occurring in document tweet 102 and occurring in tweet 107. And the other ones indeed are more sparse. We have next the frequent words. So you want to find the frequent terms, you can check for the lower frequency, which is number of 15. At least 15 times they need to occur, and then we have all those tweets that are occurring here. Indeed, you see data, minor, example, and R, which are occurring a lot. Yes?
How do you choose those thresholds though? Because like, doesn't it depend on kind of the number of tweets you look at?
Yeah, indeed, it's trial and error a bit that you're doing. So. Indeed, it's like you're checking your data sets, what gives you nice results, and playing around a bit.
don't you usually also want to set an upper limit, like closer to, like if it
Yeah,
appears
these true.
to-
Yeah, you can also just leave those ones out. But then you don't need if you have people really spamming, we also don't want to use them. Okay. For plotting most frequent words, so we have next, you will have script frequency plot. We are now converting our tweets in this way for the frequency words. We only take lowest ones at least 15 times occurring, and we will transform everything to a data frame. We're building up a bar plot, and we will put the terms and the frequencies here. And results that you're getting here is, for example, you see R, and the data in this time is occurring. So just a quick question. How many people now have internet access, or is it still? Okay. Associations. So to learn more about the word associations, you can also check this link. But it's mostly seeing like which word is also occurring more when this word is coming. You will put here a correlation factor, and if at least you have this correlation factor, these words will be occurring. You will be getting the correlation factor. So how will these,
Sorry, is the frequency the number of documents that it shows up in, or the total number of times it shows up?
This one? No, the
Yeah.
number of times it shows up.
Okay.
Okay, so how is defined association? How is this number actually being calculated? So for finding this explanation, the R website itself was, or our documentation was not really providing enough the information about it, but I actually find this answer in mailing list about R. So for example, if you would be building these documents word 1, next document word 1 or 2, word 1 or 2 or 3, then how you actually will be getting this correlation is in the following way. So you've built up this document matrix. Here you have all your documents, the words that are occurring, and then for word 2, for example, finding the correlation with word 3. These are the two vectors that you will be having here and here. You will be calculating correlation, and this is the number that will be occurring over here. And you perform next, make a word association graph, so do it for all the different terms, and you will put the correlation factor at 0.1. You get, for example, this graph over here. And some nice things that you, for example, see is you have the free online production course, you have the R data mining series, you have example programs, and you also will have here like a blog, a job that is available about for data scientists in a group in Canberra. Interesting. Okay. So similarly, over here I also tried it for my group, or for the Twitter handle for my job. For example, what you see here is you have the which one is small. This is experts. We did a talk for a podcast about marketing. You want to check that out, and also read a blog that we actually made. The word cloud. So how will you be building a word cloud? You have the term document matrix, you have the word frequencies with the row sums, and will be freezing through. These are some parts that you will be putting for having nice coloring. You will put a word cloud. If you do a play with the frequency, if you put it higher, indeed you will see less words appearing. If you put it lower, you will see a nicer overview. So again, you see the data mining, the lecturer positioning, the analysis, R, and packages are appearing. Next, again, I was also playing with the Twitter handle of my company. So you see marketing leap, the markets. So check the talk, the blogs, and here you see a wider overview of words that we're using.
Yeah, I actually have a question about the graph before the word cloud.
Yeah.
I'm sorry if I missed it, but
Yeah.
how do I interpret this graph? So I see some lines are bolder than others. What
So
does
you
that
have a
mean?
higher correlation between those words.
That means that you normally see them together?
Yeah.
Is that what you mean?
Yeah.
Okay. So the place and where the word shows up on this graph doesn't matter?
No.
What matters is just the line?
Yeah.
Okay.
Okay. So next we have the cluster analysis. So for cluster analysis, it means grouping the tweets together, which are pretty similar. If you have different clusters, it means that those tweets are more different than the tweets in a similar cluster. So two different strategies we will be using here. The first one is the K-means clustering, which I think is pretty familiar with most of you guys. And then the second one is the hierarchical clustering. K-means clustering is a centroid model. So each cluster you present it by the mean, and you will have a mean vector which is representing those clusters. You'll be first choosing k different clusters for it. Hierarchical clustering is connectivity models. The one that we will be using is agglomerative, so it means you will be starting from each term will have its own cluster, and next you will be checking like which clusters are really similar. If you will choose the ones which are the most similar, you will merge them together till you find no extra clusters anymore that you can put together, and therefore you will use the distance connectivity, and it will be presented in a dendrogram or a tree diagram. So how it will look like for the hierarchical clustering. So we will first remove the sparse terms, so the terms which are not occurring a lot, so that you only will have a lower number of values that are there. You will just build a distance matrix based on these terms, and you will fit the clustering out of it. This way, what we will see is our data and mining, they will have their own cluster. You will have the research position. This will have like one cluster, tweets about this, and next you will have still a cluster about analysis and how to use packages. Similarly, I had here, you see here the clusters for my company. Their tweets was you have wage point and small business expert, talk of April Dunford, check the podcast of our customers, and then you have a blog that was me talking about, and this one was a conference that we were holding.
Sorry.
Yeah? Yeah.
What kind of distance function did you use again? I missed that.
Cosine similarity. Yeah.
Of the term frequency matrix?
Yeah, so of the you have
Yeah.
of the different documents, you make the vectors and indeed of those ones. you build the distance metric with the cosine similarity. I didn't mention it, so sorry.
What does the height represent?
Is it?
What's the height? Like, what does it represent?
It's how deep you're going in the analysis, how much you're clustering them together. Next, you will have the k-means clustering. So k-means clustering, it means you first determine this is the number of clusters that you want to use. You first arbitrarily pick the centers of these clusters. You will calculate the distance between each data point and the cluster centers. You will assign these data points with cluster centers where the distance is the closest. Next, you recalculate. You keep iterating till the groups are not moving that much anymore. Okay. So you have, in a way, here the k-means clustering. So you set the seed for initialization to 6 clusters, and eventually you will have here showing the results that we have for the clusters. You will see some analysis about R that we were tweeting about. You have some packages and tutorials, and again you see that research pushes position and pairing. Okay. So finally, that brings us to the topic modeling. So the package that you use for this is the topic models. What does topic models actually mean? So each document can actually talk about different topics. So this is this mixture model, member model, and a document doesn't need to be only talking about one single topic, and it can belong to several topics, and the distribution might be different over different topics. So 2 methods that have been implemented for R for this are the latent Dirichlet allocation, correlated topic models. And if you want to find more information about it, there are some great papers about this online. It's actually about fitting some Dirichlet models based on and some assumptions. For example, initially you're saying the topics are not correlated. Later on, this one is a further extension of this, but you're free to read about these papers online. So what is the difference between the clustering and the topic modeling? Clustering will be about grouping all the documents together. Topic modeling is about modeling the probabilities about the terms and also discovering the information that is embedded in the documents. So we will be having this information here together. We will see topic modeling. This topic modeling, we have 8 topics extracted. These are the 6 terms that are occurring. And next you actually have occurrence over time, how these topics are. That brings us now to the end of the presentation. So these are some of the important resources that I use for making this presentation together, and you're free to ask any questions, and I will come around also there still if you need some help.